Hi, I'm Johan Lieneke and I'm the Chief Software Architect of Limark Technologies. I currently work with Lumity as a consultant software architect. Lumity is a modern benefits management platform. If you're like the most, selecting the right health insurance and benefits plan is a tedious process. Lumity takes the pain out of that with the help of data science and AI. Before Lumity, I worked with organizations around the world, from multiple airlines in Middle East and South Asia, British Telecom, Iron Mountain, Verifone, which is a global leader in payments, and multiple Silicon Valley startups. In some of these organizations, I had the privilege of helping teams to move from the relational world to the document world with MongoDB. More recently, I did the same with the wonderful team at Lumity, and this presentation is based on those experiences. In the next 20 minutes, we will be going through the challenges, dilemmas, and solutions to common problems that teams face when moving from relational to the document world. Let's kick things off with a story that happened once upon a time. Once upon a time, there was a team of engineers. These engineers were very talented and they built an awesome app. This awesome app got good traction and it kept on growing. So they had to scale things up. Scaling the application part was somewhat easy. But one of the challenges for them was, how do we scale up the database? They found some solutions to scale in the relational database, but it was somewhat complicated and unnatural. It was more like patching things up and it did not feel right. So they decided to look for a more scalable database which supports more scalable data models. Like all good engineers, they looked around and they found this awesome database technology and decided to give it a try. But when they started working with it, they found out that in spite of what's being said out there, it's not easy to use this database. It did not seem right to them. So eventually, they decided to stick to the relational database that they all know very well. Sounds familiar? This is a story that I have seen and heard many times. After such experiences, some of the engineers will be reluctant to give that technology a try ever again. And they will resist the technology in the future, thinking that it's a problem with the tech. However, the fundamental problem here is that the change is not just a technology shift. It's a paradigm shift. And to make paradigm shifts right, we need to unlearn everything we know and relearn it from scratch. Let's take a look at a similar transformational journey that Lumity went through. This presentation has 5 parts. First, we will be discussing the good old way, the architecture of the application before the change. Then, we will be exploring the brave new architecture that we wanted to build, which covers the architectural drivers that made us consider Mongo. This is the end state we desired. Once we establish the end state, we will be walking through the transition and the challenges that we faced. After that, we will take a look at Atlas, the managed cloud offering of Mongo. And finally, we will recap the key points we discussed during the presentation. The good old way. Our application was primarily built on Java technology using Spring Framework. In addition to the primary Java components, we had some Scala service components as well. Although we had multiple components, each of these components followed the monolithic principles inside. And these components talked to a relational database where we had all of our data persisted. And all of these things we ran on Amazon Web Services using Elastic Beanstalk. This architecture served us well for a long time. But however, we ran into some good problems. We experienced a rapid growth where some of our customers themselves started to grow fast and the amount of data that we had to handle for them started to grow. And at the same time, our client portfolio was growing at a fast pace as well. So this all led to a ton of data being persisted in our system, and we wanted to make sure that our system is scalable to handle the future load. So to address the good problems, we decided to scale things up. So for the application tier, it was somewhat straightforward. So we first upgraded to more powerful EC2 instances, and then we added more EC2 instances so that we can scale out behind the ELBs. When it comes to the database tier, we faced some challenges. The first option we had was to upgrade to more powerful EC2 instances, and we did that, which helped us to manage the load for some time. And we looked at other scaling out options, but it's severely restricted in relational world. So we looked at breed replicas. That helped us for some time, but we realized that we wanted something more. Anyway, the problem was addressed for the time being, but this was at a significant cost because upgrading into more powerful machines to handle the load is an expensive habit. And we knew that it's only a matter of time before we hit the limits again. To address these concerns, we decided to explore a brave new architecture. We are a bunch of geeks, so we decided to use this opportunity to explore some of the new developments in the technology landscape. But at the same time, we did not want to introduce a lot of change, and we wanted to keep using what works for us right now. So we built everything using Java on Spring Boot, and we decided to follow the microservices architecture style so that we can scale individual components up should the need be. And we wanted to use Spring Cloud as the basis here. And we deployed all of these microservices on Docker. And for container orchestration, we decided to use Kubernetes, and we deployed everything on Amazon Elastic Kubernetes Service. Now this addresses the application side of things. But what about a scalable database? And so began the hunt for finding the right database. So we looked at several attributes when evaluating the database technology. First and foremost, we wanted the database to be easily scalable, both vertically and horizontally. Also, we wanted a data model that is not too restrictive. Having support for nested data structures would be a plus here because that gives us more flexibility when it comes to modeling the data the way we want it to be. Another important thing is querying flexibility. We really like SQL and the flexibility that it brings, so we wanted to have something similar to that. Another very important thing for us was the learning curve. We wanted a technology that our relational background team can learn and productively use with the minimal amount of time. And of course, it has to be a proven technology with a good community around it so that we can get help when we run into trouble. And last but not least, we wanted it to have good compatibility with the tech stack that we wanted to use so that we can integrate it seamlessly without reinventing the wheel. So based on the criteria we outlined earlier, we evaluated the relational database against a column store and MongoDB. So from a scalability perspective, we felt that the relational database was lacking the most, whereas the column store was the best. However, MongoDB was a close second. When it comes to non-restrictive data model, we felt that relational database is right in the middle because although you have certain rules and conventions that you need to follow with a relational database, you can model a lot of things on top of it with ease. However, doing the same on a column store is more difficult because it follows a stricter data model. MongoDB, on the other hand, outshone the competition in this aspect mainly because it provides a highly flexible data model where you can have nested structures as well. From a querying flexibility perspective, we felt that the relational database is the best because it provides support for SQL and extensions which are quite versatile. On the other hand, we felt that the column store has a much more stricter querying model which did not fit in well with the dynamic nature of our queries. Now, when it comes to MongoDB, we found out that the JSON-based query model of MongoDB is quite flexible. Now, there are certain operations like group by that the JSON model doesn't support, but in those cases, you can always use the aggregation pipelines. When it comes to ease of learning, we felt that the relational database is the easiest to learn because most of the people are familiar with it already. However, the column store seems to be the most difficult one to learn because it brings in a lot of new concepts and restrictions along with it. MongoDB, on the other hand, was fairly straightforward for most of the people coming from the relational background to learn. When it comes to compatibility with our tech stack, we felt that all three has very good support from the stack perspective, but however, the relational database and Mongo had better support than the column store. So based on all that, our overall ratings look like this. And the winner is, of course, it's MongoDB. We really like that MongoDB can easily scale via replica sets, and the document-based data model without a schema is quite flexible to us, and it helps us to have the support for nested data structures as well. And the querying flexibility with the JSON syntax and the aggregation pipelines is very useful to us. And MongoDB fits very well with our Spring stack because Spring Data has a Mongo subproject which provides the familiar Spring Data abstractions for integrating with MongoDB. And compared to other solutions that we looked at, we found out that it's easier for our relational developers to learn MongoDB than many other solutions out there. Having said that, let's take a look at the transition that we went through. Like I said earlier, moving from relational to MongoDB is a paradigm shift. There are some things that we have to unlearn, there are some things we have to relearn, but of course there are certain concepts that can be mapped between these two paradigms as well. You can think of a table in the relational world as a collection in the MongoDB world. Likewise, a row becomes a document and a column becomes a field. Having said that, it's very important to remember that not all the properties that you know about a table in the relational world will apply to a collection in MongoDB world. There are subtle but very important differences. When you're doing data modeling with MongoDB, it's very important to use the data read and write patterns to drive the data modeling process. It's always a trade-off between performance and consistency, and based on your situation, you have to favor either one of these two. Another very important distinction here is that the normalization concepts are not important anymore. It's perfectly fine to duplicate things in the MongoDB world. For many relational database developers, this is a hard one to get because normalization is second nature to them, and duplication is frowned upon in the relational world. We need to let go of that mindset to do MongoDB right. Another important thing to pay attention to when modeling data is to decide whether to embed or reference an association. In the relational world, generally the preference is to reference. But with Mongo, we have the option of embedding an association as well. So this is something to keep an eye on because generally a team that is coming from a relational background will always prefer to reference data, and that might not lead to the best experience with MongoDB. In fact, that could lead to a relational design on a document database. In my experience, this is one of the key reasons why many relational development teams fail to adapt MongoDB correctly. To quote the conventional wisdom, don't try to put a round peg through a square hole. Let's talk about embedding a little bit more. Embedding results in very fast load times mainly because everything is self-contained with that document. When you go to the database and when you ask for that document, everything gets loaded at once. It's a single fetch. Whereas if we do the same thing with referencing, we need a second fetch operation to get the dependency. This works great for situations where you want to embed a single copy of that dependency. But if that dependency is shared, then you need to make duplicates of that. Now, duplicates is okay, like I said, in the MongoDB world. However, when you make an update to that dependency, then you will have to go and update all of the copies to make sure that everything is consistent. So depending on the use case, sometimes it makes sense to have one copy of the data and reference it from other places. So when should you use embedding and when should you use referencing? In object-oriented design principles, there are two types of associations: compositions and aggregations. We can use this information to decide when to embed and when to reference. A general rule of thumb here is that you can use embedding for composites and referencing for aggregates. However, it really depends on your use case. For example, sometimes you might embed an aggregate so that you can improve the performance of the entire operation. One thing to be cautious of is the size of the document. When you embed more data in a document, the size grows. And when the document size grows, the memory requirements for loading that document grows along with it. So if you have a query where it returns a large number of documents, and if the document size is large, then obviously you need more memory to deal with that result set. So this is something that you need to be cautious of. So we can use embedding as an optimization measure to improve the performance of the application. But we should always remember that premature optimization is the root of all evil. So moving on to referencing, We generally use this for aggregates. And especially if the same document is being referred by so many other documents, referencing is a better fit than embedding multiple copies, because in case if you have to update that data, then you only have to update it once. When we use referencing, generally what happens is that we use a second query to fetch the data from the target collection. So there is a performance impact that happens out of this. This is very important to know, because if you use Spring Data and if you decide to use @dbref annotation, you should know that it leads to a second query. So from your application code, you might ask for just one document from the database, but it will lead to two queries so that Spring can fulfill the request to load the dependent data using the DB reference. So it might look like it's just a single operation, but in fact, behind the scenes, those are two fetch operations that runs. Moving on to some other observations and learnings that we had with MongoDB, one thing is that you should embrace the object ID. So don't try to implement your own sequential numbers approach or even use UIDs, because object ID is just more than a random number. For example, object ID contains the timestamp of the record creation in it. So you can always decode the object ID and find out when a record was created if you need to do so. Just like in the relational world, you have to pay attention to the indexes. MongoDB supports a wide variety of index types, from single field, compound, multi-key to geospatial indexes. Based on the indexes that you have defined and your querying pattern, Mongo will decide which index to use, if at all. And how this all works could be a separate session of its own. So if you want to find out more information about this, I would recommend going to the Mongo University, and you can find out all the information there in the website. Another thing to remember here is that indexes do cost storage space. So you have to be mindful about that. And one thing that you can use here is partial indexes, where you can give a condition so that only a certain set of documents that match that condition will be indexed. Also, feel free to take advantage of the dynamic schema in MongoDB. So you can change the schema on the fly. There's no rigid structure here. But one thing to be careful is about having backward compatibility. For example, if you add something or remove something from your data structures, you need to make sure that when you read that old version of the document, that old structure of the document, your application can handle that. And one last thing to note here is that when you're querying data, if you are using aggregation pipeline, that's quite powerful. So it can do a lot of things that the regular JSON-based query structures cannot do. So if you're not familiar with it already, make sure that you read through the aggregation pipeline documentation. That knowledge really helps to shape up the queries and what you do with MongoDB. Now let's take a look at how MongoDB works with the microservices-based environment. So one of the best practices in the microservices world is to use a separate database for each of the microservices, so that you don't want one microservice to go and access the data of another microservice behind the scenes. You have to always use the defined API to do that. So one way to model that in the MongoDB world is to have a single replica set, a cluster, and then have multiple databases within that cluster, each of which is mapped to a microservice. So a database in the MongoDB world, in this case, is more like a relational database schema. Another interesting topic is transactions and microservices. So inherently, it's complicated in a microservices world, because you have separate service boundaries, and orchestrating a transaction between all of those services, it's not easy. So there are various approaches that you can take, and MongoDB, starting from version 4, has support for transactions. But out of all the options that was considered, we shortlisted for our use case two approaches. One is to use rollback routines, which means the application needs to handle the cleanup and all that and accept the fact that the database can be inconsistent. Or the other one that you can do is to use the Saga pattern. So I have linked up the definition of Saga pattern over here. So when you're doing Saga pattern, you need what's called a long-running action coordinator. You can think of it as a transaction manager for the microservices world. So one solution available out there is the Eclipse microprofile for this. So it's called Narayana. So I have added a link to that over here as well. Moving on to integration with Spring Boot. So we used a library called Spring Data Mongo to handle the object document mapping. One thing to note here is that the new version of the Mongo Java driver has the capability to do this object document mapping out of the box, but we decided to stick with Spring Data Mongo, mainly because we had a team who are familiar with the Spring Data abstractions, and we felt that's easier for us given our prior experience here. And you can use that library to get the familiar Spring concepts when you're working with MongoDB. And if you need fine-grained control, you can use Mongo operations object so that you can manipulate the database directly. Given the schema-less nature of MongoDB, you don't need to do schema migrations, but what helps is to have some sort of like data migrations. This allows you to populate seed data and also to have different test data in test environments. So initially we used this library called MongoDB to handle these migrations. This works similar to how Flyway or Liquibase works in a relational world. But MongoDB is not maintained anymore, and it does not play nicely with the new versions of Mongo Atlas. So we decided to move on to Mongo, which is a fork of MongoDB, but it's being maintained and it's slightly different from MongoDB. It was not a direct drop-in replacement for us, but it works well with the latest versions of Mongo Atlas. Now let's talk about how Mongo Atlas can help. So when we started off to use MongoDB, we had a dilemma. So should we use MongoDB on Docker and manage it ourselves? Or should we use a managed solution like MongoDB Atlas? So we decided to stick with Atlas mainly because of these reasons. So first of all, it has first-class support for AWS. We are running on AWS, and you can just go and with a few clicks set everything up and connect Mongo Atlas with your VPC so that you can communicate with the database. And similarly, it has support for GCP and Microsoft Azure as well. And because we went with MongoDB Atlas, we don't have to worry about backups and point-in-time recovery because everything is available out of the box. With a few clicks, you can set all these things up. And it has support for automatic patching and one-click upgrades. So these are great features that we take advantage of. And if we went down the path of running our own MongoDB, we would have to take care of all of these things. And Atlas has built-in security features, including access control lists, so that you can better protect your database. And one feature that we really like here is that you can set up rules to grant access to certain IP addresses, which automatically goes away within a certain number of hours. So this is useful, for example, when you want to connect from your local machine to the database. You just need to go and set up the rule and say that I want it to be expired within a certain number of hours. Then you don't have to worry about removing it yourself. And another cool feature of MongoDB Atlas is that it has a fantastic set of monitoring tools that tells you about the health of the database cluster. And it has an alerting mechanism with performance insights. So if it detects a slow query, for example, it will let you know, and it will propose that you need to add an index to improve the performance here and things like that, which is really helpful to us. So in conclusion, we feel that MongoDB Atlas really helped us out to eliminate the possible bottlenecks in the data tier. So we had initial hurdles of the paradigm shift, and what I presented earlier are based on those experiences. So once we got through that, we felt that our developers are far more productive with the new architecture and with MongoDB. So one thing to note here is that getting the data model right takes a few iterations, but the flexible structure of MongoDB really helps you to course correct when you run into those situations. So all in all, we feel that choosing Atlas was one of the decisive decisions we made in this process. So with that, we had less maintenance headaches to worry about. Backups, patches, upgrades, all of these are taken care of. And the performance insights are truly a gem for us so that we can have an optimal database. And it's as if you have another pair of eyes looking at your database telling you what to do. So with all of that, from a value for money perspective, we feel that going with Atlas was a significant cost saving for us. So with MongoDB Atlas, our developers are living happily ever after. The end. That's all, folks. Thank you very much for your time, and I hope you enjoyed the session.